Hello and welcome to episode number 5 of the AI Boardroom. And of course, I'll call you Lana from that point.
That's good. I don't mind. I don't mind either Svetlana or Lana, but
Yeah, Lana is really
Lana's
cool.
more common.
I think it's a cool short name. I like it very much. How are you doing? How was your week?
Busy week, I think, for both of us. We were just kind of chatting. Yeah.
Honestly, I enjoy a chat beforehand as much as I do the actual podcast itself.
Well, we launched officially this week, so
yeah, we did.
With that came a lot of excitement and a lot of just kind of work behind the scenes. But really excited to finally get some of our episodes out.
Yeah. And I think the first one and the fourth one did the best. And I'm pretty confident that the further we go, the better the episodes will get. So let's stay with that. Let's start with the news section. That's what we're working towards by releasing all episodes at once, so that we can do them weekly and include the news and give you guys some context and what this means for you. Of course, let's start with, I think, one of the biggest or bigger news this week is like Mistral Large launched, and at the same time they announced that they partner up with Microsoft. Microsoft's investing money.
You mean Microsoft cheated on OpenAI?
Yeah, that was the headline basically. Yeah. So kind of. I even heard someone saying like, I think they don't believe anymore in OpenAI what they're doing, and I was like, mate, they did it with everyone. Like, you can have basically every open source LLM on Microsoft's platform, and now you get the Mistral like additionally. Microsoft's they don't care about any of the AI companies, I guess. They only care about getting the stuff into their products.
Well, I think, and it's also it's an example of diversifying portfolio, right? So you're kind of investing into multiple things, hoping that one will stick. And I think, was it December where this whole kind of multi-day havoc that happened at OpenAI? I think that kind of also, kind of left an aftertaste, I think, in Microsoft's mouth.
Honestly, it's their infrastructure that failed, so I'm not sure who's to blame on that.
No, I mean the board firing Sam.
That one. Okay. I thought you meant
like
you meant the outage, but yeah, you're right. Yeah.
Yeah, so I think it's what could have happened. I think they then hired Sam Altman into their organization, and then Sam ended up coming back, and it's like there's just so much happening.
It was such a live telenovela. It was really nice. I was going on Twitter. I'm never on Twitter, honestly, but I was going on Twitter seeing if someone of them is posting something new, like hourly or something.
It's like the soap opera ends. Yeah. Like, I need to know what the next thing is everyone's doing.
Yeah,
but I think that's basically, I think maybe a big move. Why is because OpenAI Microsoft doesn't want to put all of their basket into OpenAI, and they're like, okay, well, what alternatives can we have? How do we diversify our portfolio of foundational models that we offer to our customers? I think that may be one of the reasons. I'm not saying that's the only one, but
Microsoft also always worked like that. So I'm working in the Microsoft universe for my whole career, and I'm pretty familiar with how they work and what they're doing. And to be honest, they always try to spread all the lines out. And I always was like, if you have this acronym FANG for Facebook and Apple and Netflix and Amazon. And Microsoft's not even mentioned in there. And I always was wondering why, because, like, of course they hadn't had the best years, like in the beginning of the 2010s. Mm-hmm. But to be completely honest, they always were so hugely spread everywhere that they're not going anywhere. And I was always wondering why, like, Silicon Valley is looking at them as a bit of like the old Microsoft guys. Honestly, they were, and if Ballmer would have stayed president, they most likely would have died. But everything got a swing with the new CEO. But yeah, what I'm excited about, I'm a really big fan of the Mistral models. I think they are already at a level without Microsoft's funding. And as we all know, compute is like the one bottleneck for everyone doing stuff with AI and honestly for AGI most likely. So if we would have had like infinite compute, then AGI would be like right around the corner.
So do you have any experience working with Mistral's models?
Yeah, I use the Mixtral, the mixture of exports model. That's like the one I use when I use the local one.
Okay.
Because it's basically par on one level with GPT 3.5.
Okay.
And at some tasks it even performs on the level of GPT-4, and it's running locally on my computer. It's really cool. I really like this model. I'm still like on a side mission to figure out how to how to integrate small models into production.
Mm-hmm.
And performance is of course the main reason for that. And like I think we also said in the last episode that thinking about using a small model for a specific task might be the better way to go than using a general one.
How much smaller is it? Do you know? How much smaller is Mistral?
Mixtral is not that tiny. It's, I think, 48 billion parameters, but it's 8 times 7, I think. Mm-hmm. So there are 8 or 7 models, are 7 or 8 billion parameters. I'm not sure
Gotcha.
which way around. And of course, there has to be some kind of router, like picking the exports. What I wasn't aware of is that the inference goes through the whole stuff. So it's not like in the beginning there's a router picking 2 models and then they work on that, but like it's going around and
inferencing each one.
As far as I understood, I tried to get some grasp on how mixture of exports work. But yeah, you have a really, really good model, and being at a position where a year after ChatGPT launched, having an open source model just being on par, I thought it's a big achievement. Yeah.
And I'll take a stab. I think also explaining why having multiple of these models is really key. But I may be wrong, but please correct me. But the idea of using just one huge model is that typically it's a one-way street. So you basically ask the system, and it's called basically fast thinking. So for those who have read the book Thinking Fast and Slow, so it basically inferences you prompt the system, it goes and creates an output very quickly. And so you've seen probably then within a few seconds you'll see an output. It's basically it's just going one-way street. It goes picks the right kind of words, and then it gives you the output. The power between these different models is that now you have an opportunity to think slower. So instead of running that prompt through one system, it's basically, throwing that against, across to another model, and then it thinks again, and it looks, okay, am I equipped to basically answer that question, in a much more detailed, deep fashion? No, and then it just continues to inference other models until it feels confident in providing an output. But I think the big difference, and I think we talked about this more, I'm just curious on your take, is that because you're ultimately running that prompt through multiple of these systems, that's where the slow speed comes in. Because instead of having you prompt one system, you're now prompting ultimately 7 or 8.
Honestly, it depends how you classify speed, because, for example, GPT-4 is also a mixture of expert model.
Uh-huh.
And that's a bit of like... Usually you might think, or like I think it comes naturally to think about having several small models. How can they be better than each model itself? Like how can be the sum of the parts bigger than the one? But it is, and it's really fascinating for me to see. It's one of the most interesting technologies we have at the moment. Is this mixture of experts model, because you really have different small, fast inferencing models combined, and and the router always picks two and works with two of them. So, as far as I understood, like there will be different strategies and stuff like that. I think that's something where then the provider of the model can fine tune stuff. But in the end, it's faster than having the one big model, because if you would have to inference the 48 billion parameter model, the output would be worse and it would be slower. But inferencing 7 billion is like it's just a lot faster, and that's basically you have, of course, a bit of overhead for the routing and stuff like that. But in general, like if you have an index which like takes into consideration quality of the answer and speed, that mixture of experts model is faster if you keep the quality the same.
That's interesting. So do you think also compute, like the power of compute that you have available, does that play a part as well?
Always. I think in the end everything comes down to math, and you have to multiply vectors one way or another. There is no secret key. We also, the only reason why we can even do all the AI and vector stuff is because some 6, 7, 8 years ago found a more efficient way to multiply vectors. And that's the only reason why we even can have billion parameter models, or like trillion parameter models, because like, of course the hardware gets better, but in the end you have to do math, basic math. And so it's also, if the model has a certain size and certain parameters, you basically are stuck with the same inference time on the same hardware. There is no secret sauce. For example, Google, I think they just have really, really good hardware, but the model itself, if it's like if the GPT-4 and Gemini were just the exact same size on the exact same hardware, that would inference the exact same time, even if there are two different models. That's it's kind of interesting. In the end, it's all about probabilities. So, but still, I think it's really interesting to look at the stuff and to see how we can use small models. Also, a news this week: there is a new API called Groq with a Q in the end. And they have extremely fast inference, and they also have this mixture of expert model from Mistral, like this Mistral online, and it's basically, it's close to instant that you get the answers, which is kind of cool, because like I said, it's on the level of GPT 3.5, and with Groq API you could inference it like in basically no time. That's really, really cool.
Do you know? I think you mentioned that it's also a library of different models too, right? It's not a single.
I think right now they have Llama 2, 72 billion, and the Mixtral model. I think that's the two that they offer right now, with more following. And they're also in the beta of the whole stuff.
So what makes them different though? So if they're using Llama, an established model, so what is Groq doing different than if you were just to basically get that model from one of the cloud providers?
It's just fast. I don't know if they might have specialized CPUs for that, compute units, because there are chips. There even is one company, they do transformers in silicon. They bake the transformer architecture into silicon, and the chip is the only thing that can do is do inference on models. But that lets you do stuff in near real time. And if you go to multimodality and have audio processing and stuff like that, and live video feed processing, then it gets really interesting. Of course, they are screwed if transformer models are outdated and we have something new. But I think it's worth a mention. I'm not sure how Groq does it. I only know that they're really, really fast, and I can compare it to basically my experience with Mixtral, and if they can keep it up even on scale, I think it's pretty interesting for small stuff like summaries and things like that, because they're basically a lot lot more usable. Also, I've seen one demo using it for a live call script retrieval. So they did the Whisper stuff. They then called the Groq API, and they were just a lot faster in retrieving the right documents.
But you suspect that it's hardware mostly?
Hmm?
You suspect that it's mostly improvement in hardware?
Yeah, I guess so. I think it's the cloud is just focused built on inferencing.
That makes sense. Should we talk about Elon Musk's lawsuit?
Yeah, that's honestly the other big elephant, the big Elon in the room. Yeah.
Yeah. So Elon Musk sues OpenAI for reaching the OpenAI's original kind of nonprofit mission, which I think we talked about a little bit before, but ultimately, and I'm looking at Reuters, it basically says that, Musk lawsuit alleges a breach of contract, saying that Altman originally approached him to make an open source nonprofit company, but the startup established in 2015 is now focused on making money. So, and the big question that I think we talked about is like, why is Elon Musk even suing in the first place? And I think you had some kind of interesting ideas to offer there.
I always think like on what ground, but to be honest, from me being a German sitting in Germany and looking at US law is always funny. Honestly, I've seen suits, so I'm basically an expert in American law. No, to be honest, Elon was invested into the into the non-profit part, as far as I understood, and was sitting there on the board. And I'm not sure how things went down, but shouldn't he have been aware back then that they are going to make a new entity out of that is for profit? So, but he just didn't invest, and now he's like sad about that. I don't know.
Well, and I think the other big question I think we both asked, it's like, Musk, you have so many different other initiatives to focus on. Why the heck are you even spending time suing OpenAI? And
it's the same thing why he thinks about buying Disney. Like he's a man with a lot of ideas, with a high IQ and a lot of money to spend. And like I think he doesn't. I think he's not even caring about if he's broke tomorrow. And like he's just he loves his doing an idea and his being so much that yeah. The only thing, like I liked Musk for a long time, and I liked what he was standing for in terms of pursuing things that no one thinks are possible. If you, I read or have had the audiobook of the autobiography, which was not written by him, but it was written by someone who just wanted to write about him, and he was like into going and like uncovering Elon, and like the further he went down the book, he just got to understand him more, and I think it's also something that like stick with me. But the last years, I'm not sure if he's getting ahead of himself a bit. And that's sad to see because he's brilliant, and I think his methodology is questionable. If you ask ex-employees, like they mostly broke under him, but they also achieved things no one thought are possible. So, like the big minds are always kind of broken themselves. So. I'm not sure. I'm all for getting into the future and being like and pursuing the future. But meanwhile, he's talking a lot and delivering not that much. So
interesting. Are you talking about the book that you're talking about? Is it by Walter Isaacson?
Yeah, I think it was the one. Yeah.
Yeah, I love his book. So I think it's on my reading list. So I think I've started actually reading the book. I haven't finished it, but all of the books by Walter Isaacson are really excellent. So for those who are interested in what we're talking about.
Yeah, and I thought it's inspiring is maybe not the right word, but having such a good deep look into someone like Elon Musk, who's a really special character with a special background. Yeah, it's kind of interesting. But like I said, I think he got a bit ahead of himself, and I'm a bit iffy on him right now. I hope that he finds some time to reset a bit and focus on what's actually in front of him.
Do you think it's also this lawsuit kind of a part of his own models in X competing with OpenAI, or do you think that has nothing to do with why?
Of course, I think he has an agenda through everything he does. Like he didn't buy Twitter out of a like
goodness of his heart.
Yeah, or out of a like bad Sunday or something. I think he has a lot more of a bigger picture and plan than we all think he does. But like I said, I think the death of every great mind is the hubris going along this. I talked to so many really good people that are successful business owners, and they always have this notion of hubris. How's the English hubris, right? Pronounced. And you always think like, mate, come back to earth. Like, try to. You're not the Messiah at all. And the further you get and the more successful you become, the more I think you're inclined to get ahead of yourself, and that's always, or like oftentimes it's a bad sign.
Yeah.
And you should take a step back.
Yeah, slow down.
Yeah. But talking about Elon Musk, they also have a humanoid robot. And the whole robotics space kind of got a lot of drive with LLMs because basically the machines get new brains with all the transformer technology, and that's kind of interesting. And there was a new investment into a company called Figure AI, and they build humanoid robots. I think the demos showed them like making a coffee, and they're like at the beginning, but they achieved to get like $675 million this week. And one of the investors was OpenAI. Another investor was Microsoft. And maybe it's also something that triggered Elon, because Tesla is building the humanoid robot themselves. So
everyone's doing it. I think Meta is also have their own version of a robot too. They posted a video that actually has a pretty great gait in comparison to future AI. I mean, I don't know as much as into the technology. I haven't dove deep into it, but I mean, just I was assessing as to like, how is it, walking and actually performing on like the physical space? Because I mean, there's been a lot of improvements there as well. Future AI is just, it still seems a little bit behind, but as you say, like, it's not only about like the physical, it's about its capabilities.
Figure AI, yeah.
Figure AI, I'm sorry.
Yeah. Jeff Bezos is also invested, as I just seen.
Oh.
They're like, there's a lot of money going into that. Like, it's like always. I feel like it was even worse, but it's still like, if you have an idea, there's some AI label somewhere in there. But as far as I understood, Amazon also is or Jeff Bezos especially is really interesting, because Amazon builds its own robots for their facilities too. So maybe it has something to do with that. But yeah, there's a lot going on. I'm really interested. Also, there was this UC Berkeley or Stanford? I'm not sure. They published an open source robot. They published the software and the part list, and they're off the shelves parts. And it's really, really interesting. It's I think if you buy all the parts. It's like $32,000. But then you have basically a robot, and he has a learning mode, so you can take the controls, do stuff with that, and then the demos were really cool. It makes you eggs and stuff like that, so it's really able. Like just has like some robot arms, like just for grabbing, and it really was like a really interesting project. Especially thinking about it's open source and everyone can build this at home, basically.
A good project for kids.
Yeah, kind of. Yeah, for me, it was cool to think about this because I was thinking, okay, maybe I'll put up the 32K, buy the stuff, build this thing, and see how far the base model goes, and then you try to just improve on that, right? Maybe you get another base for which is not as bulky. Maybe you get it even feet to walk. If it's even necessary. Maybe you improve on the whole shell to make it like more less like looking like a prototype. So and then it might be necessary for you to charge then like upwards of 60-70K for such a role. But like, what is that if you have compared to a year's salary of a human?
Yeah. But do you think that the big question that I think is pending in my mind, have they built a vessel for AGI, but AGI is not really here. So how effective would these robots be, even if you get them to,
but do they need that?
And that's the question, yeah.
I don't think so.
In order for them to operate, do you think that AGI needs to be reached, or do they need to be also task specific, and that's what we would consider sufficient?
I think AGI might be necessary at some point to solve the underlying theoretical problems. Basically, for example, having a less friction motor, or like I don't know the English word, but like everything that moves breaks at some point. And to get like if you look at human hands, we move for 60, 70 years if you look without any issues. So like you really don't need a lot of service for a human body, for especially considering how much it moves. So biology has that solved. We do not, and that's something AGI I think might help, like how to be able to recreate what biology has already been able to do over evolution, because it needs so much processing, so much time, and so much research, and having AGI could speed that up. It's the same for everything. It's the same for climate change. So that's what AGI is really interesting for, to solve the problems we just don't have the time to with our human minds. And
so in your perspective, you think that if we train these robotics, and I'm just kind of thinking like, well, how widely spread do you think they will be in 5 years, and what would be a fair expectation of them, for them to again solve specific tasks around the home? Is it still going to be?
I think for us in the home, it's still like 20 years off, maybe 10. But I think like the rich people, like really rich people, they might try it earlier. Like Musk might have one version of the robot already at home. I don't know. But for being at like a car, which you just own, I think that's a bit off still. That said, for companies, that's a really interesting development, because not only to get rid of actual humans, but to really get dangerous stuff done by machines. And maybe even if you have to have someone controlling it remote, if that's working properly, to have it work remote with an intelligent core to avoid mistakes, might be something to think about, because it's already more efficient, and you might be able to be more productive as a company. So I'm honestly a bit irritated because why Boston Dynamics because like they were so far ahead in robotics in like in every way, shape, or form. Why aren't they putting out new stuff with integrated transformer models and stuff? It's a bit weird.
Resistance, maybe.
I don't know.
But there is, one other use case that I think you've mentioned. This could be game changing for bigger companies. So I think the hospitality industry, they've had some track record of using robotics already. So they're probably not as advanced as the ones we're talking about here, but actually answering questions. I don't know if you've seen them, but there's some versions of robotics. I'm trying to look it up right now, but where I've seen them actually like bring stuff to the rooms or clean. There's other ones that greet, people coming in through the doors and things like that. So there's could be maybe a use case, as you kind of mentioned, like maybe for companies to leverage them for things. But I'm just curious, like how would we be able to feel it in the industry in the next couple of years? I think it's probably, these customer experience still, like maybe the hospitality is who we would anticipate adopting them first.
Maybe, but to be honest, I'm not like at least we have like the town I lived before in Hamburg. We have like an Asian restaurant, and they have a robot bringing you stuff. But it's more of like a programmable wheel, a programmable tray on wheels. And then you have to take the stuff from the tray, and then it also has like a display with a smiley face and stuff. And it's just uncomfortable, to be honest. It's just making me feel uncomfortable, and that's I always said all the technology in the world will not replace human interaction and human hospitality, because, or at least that's the last frontier that will be replaced. Or maybe everything, like I think we had in episode 2 or so, everything human made will be just so expensive, and like you have to go the artificial and automated route. I don't know. We'll see.
Yeah, no, I mean, amazing developments nonetheless. I think, we'll just have to kind of watch, but I think it's really interesting that how many of these companies are emerging, as you mentioned, like Boston Dynamics is not kind of even competing in this space, but then now you have all of these other players like Meta, as you mentioned, Figure AI, and others emerging out of thanks to large language models, and then them being smart of leveraging that technology to actually better their robotics, I think, in the very short term. So it's exciting to see. Yeah,
and I also think if you want to start a new company now, or you want to have some like real cutting edge technology company, look into robotics. I think that's honestly one of the best bets you have, because in an economy where AI is leading everything and everyone, and AI is making for good robots, you are the one. You want to be the one building the robots. So I think from that point of view, and you don't even have to start fresh. I think just the building capacity we will need for that stuff will be so high. You might even focus on building motors and stuff like that that are more efficient, or come up with some efficient part that's allowing the robots for less service or longer lifetime in general. Because that's my biggest complaint. I was like I was driving through the city after autumn. All the leaves were on the streets, and no one bothered getting rid of them. And then I was going to this train station. I was thinking about how could a machine look like that does this. And always, every time when I think about robotics and stuff like that and automate stuff with robots, I always come back to the service cost and all the things that can go wrong in a certain operation, where the robot is not flexible enough to get rid of it, and you have to step in as a human. And I think we're still at an age where robotics are not as or need so much service that they get impractical for a lot of stuff. Mm-hmm. Well, we'll see. I could imagine the best ideas I have for automating stuff with machines is always connected to drones. For example, like drones that are able to paint a wall, or just set up four drones in a room for every wall. They fly up and down. Room is ready. It's painted. So that's that's stuff that I can imagine that also from a mechanical standpoint can work. But that's what you have to think about. Like, look at Tesla. They build cars for now close to 20 years soon, and they still don't get their doors right. So,
yeah, we'll have to see. But it's
building
an
stuff is hard. Yeah.
And I think, as long as, even with all AI systems, as you kind of build it, that you first need a signal that it works. And so maybe that's where they're kind of doing it in phases, right? So you kind of have to, you can't solve for everything at once. And so I think definitely. Probably, as you kind of mentioned.
You have to start somewhere, yeah. That's the same with all, like the Vision Pro now, Apple released it. It's a first-gen product. Nobody knows what to do with it. But maybe like 5 years down the line, we were like, of course, this was going to be fun and entertaining and the future. like after 10 years, everyone's smarter.
Yeah, no, and but I think some of the things that you've kind of mentioned, maybe even the technology isn't here. So, but still, what we've built, something is better than nothing. So,
yeah, definitely. And we have a lot of stuff that has to be done, and we don't have enough people to do it. So robots might be one way to fix that.
Yeah.
Just saying.
Yeah. Well, we'll continue to watch and report back what we kind of understand and know. But yeah, definitely some really interesting developments this week. So should we dive into our next topic that we wanted to kind of spend a little bit more time discussing? Or do we have other things to dive into?
Yeah. That's your topic from Friday's post, I guess, right?
Yeah.
On LinkedIn. So, then who would be better suited to introduce us to the topic?
Where's the robot?
I'm really glad you're not a robot.
So I think I'll just kind of give folks a preview as to what I was talking about. So there's been, a project that I was working on. There's multiple. I mean, this is an application for most AI products, and it's going to become more and more important for companies to consider explainable AI as part of their solutions right from the beginning. For regulatory reasons, right now, not everyone's kind of adopted those regulations kind of cohesively across the world, especially in the United States. We're a little bit behind other than California and maybe a few other states that have some regulations, but it's just maybe not as widely spread. But as you kind of build, and one of the things that, I was working through is there's just a gap in understanding in why we need explainable AI in the first place. So I just decided to write a post about it, that I think as we build these solutions, it is so important to bridge the gap between people considering AI as a black box and understanding what its output is. And so the way to do that is explainable AI. And so what it is and how it works, but we'll kind of talk about more, but that's one of the essential pieces is, if no one really adapts AI in your organization, you can't capture value from it. And so if people don't trust AI and how it works, then how do you build that trust, right? So you have to kind of start pulling back the curtain and really explain how AI works. There's multiple ways to do it. So there's change management, communication practices that you could, kind of implement or plan for. But how do you actually surface evidence in your AI solutions, basically the front-end user interface or some interaction interface that your consumers are basically communicating with these AI models. And I think that's what my post was about. And, it picked up a lot of conversations, I want to say. And so I was like, yeah, I think this is something worth kind of talking about. And just curious, if other listeners have had some experience with this. But I do think that, there are industries that do this better than others. And again, part of it is being regulated. So you'll see, law, medicine, like healthcare, being one of those that, there are evidence-based industries. So they rely on evidence to reach their conclusions. And so they expect everything that is implemented to have evidence behind it. So they're not just going to take a decision just point blank. Yeah. So they need to surface something behind how the heck did that, machine learning engine or large language model surface that evidence. And this is why I think initially we heard about like, well, can we source sources? Like we can't trust that output because we don't even know where it's sourcing that information. We can't just take it point blank. Because, and then there's also a risk because of hallucination. So how can we trust this output if you're first not even surfacing the evidence and telling us like how this model came with its output? And I know you more than anyone also, Edgar, are working on hallucinations. And one of the things that people want to know is, well, how the heck do we avoid them? How do we build that trust that truly what the machine had output is true?
Yeah, I think we also wanted to do an episode about prompting, but I might pick up some strategies from there. So basically, let's just think about a large language model and how it generates information. Like it gets text and it takes parts of the text and tries to add to that create an answer step by step, token after token. So it's not really possible to know what route has this token went, and additionally to that, said route wouldn't even say us anything because we don't know which parts of the brain of the LLM do which decision. So one way to get this straight with large language models especially is to go ahead and ask the model to not only generate an answer but also generate the reasoning for that. That in and of itself works partly, but it's also tricky because if you then have a trained large language model which knows like that you asked for the reasoning steps, it starts to hallucinate in the reasoning, which doesn't make sense at all. That's why we often use RAG and stuff like that, and lower temperatures, like lower creativity on the models to reduce the hallucination part, which makes the whole topic really, really interesting because from a conceptual standpoint, from a mathematical standpoint, hallucinations are basically not solvable, as far as I understand them right now, because it's just the way transformers work is making them just generate the next token and again and again and again, and that's all what we have now is just the result of the next token generation being that good that we can actually use it. And so, what you I think you told me about a product which you can buy for Explainable AI. How does such a product look?
So I don't probably not buy, but you could implement some of these tactics. But going back to what you just kind of said, and I've been really impressed by, ChatGPT and like maybe Perplexity also, because they claim to surface evidence, and they sometimes even go into that system and they fact check another LLM's output, and they'll literally just take the output and then I'll premise or like prompt fact check, and then I'll put the whole output in quotes. But that's basically what you just kind of said, and I just wanted to emphasize that again, is like these transformers, the way that they're built, they don't house these libraries of text like these billions and billions of data sources that they're trained on. All they do is they find patterns in language and they just store gestalts. So it's just basically the essence of speech, like the pattern in language and everything like that. So, and all of those patterns come from like so many different sources that it's really hard for you to, as you mentioned, like know, did this combination of words come from this source or like what idea came from whatever. So when I think ChatGPT, for the longest time, they didn't have the ability to source data because it's really hard exactly for that reason. Like, how do you source where in the brain that information came from? So I think I was And it comes from maybe misunderstanding how these systems work, because I do think that some people do believe that all these large language models do is like they're just better data curators, but they're not. They don't have libraries that they just look up information from. But what's really impressive is how, I think it's Perplexity. They have a group of models that they use, but ChatGPT in specifically, that they now can source data, so they must be indexing something or somewhat to be able to even surface some evidence behind, not everything. They don't do it in line with every single sentence, but just the fact that they're able to do that, like that's really impressive.
Yeah, and I think that's one of the most powerful things LLMs brought to us, because thinking about a language processor which you don't have to pre-program, but it's still able to classify text, and that's the beauty of it, and that's you can do so much with it, and that's what we are working on too, is to make the language processing part the genuine value addition. So because what are we humans doing different in a lot of circumstances? We get in some text, which is basically a pattern containing information, and we try to find the right pattern matching to the initial request by answering in words. So that's the interesting part. You have to, like we oftentimes say on the podcast, you have to break with the old thinking you have about how a computer works and how you program stuff and how you develop stuff and even think about solutions, because in the end you have to think about it more like how language works and how language processing works, and that's how you come by how to work with LLMs. And that's also where you better understand how hallucinations are going, because it has to generate the next token. It will do this even if it hasn't have a proper answer, because not having a proper answer is just, it gives an output which has a lower probability of being right, but it's still an output, and that's how the hallucination is going to happen over and over again, because it gets a pattern which is either not able to correctly find the matching pattern to, because lack of data, lack of training, whatever, or it just takes like the best probable solution and gives it back, and this best probable solution, even if it's a matching pattern, might be off slightly because the probability of it being right was only 67% or something, and that's basically how you have to look at it. It's just, it always gives an answer, but it gives always the most probable answer, but the probability might be too low. and indexing stuff, pulling out from external sources for a proof helps a lot mitigating this, because you say, okay, I have this answer, the probability is low, and it doesn't match to any documents I have. There comes the language processing part again. I can match the answer with other text and see if it correlates, and give an answer to that, which is a lot higher because the language models are really good at understanding texts.
And I think you said something that's really key. So this is one example that I think with large language models that I think is so widespread, but it's really important to understand that all of AI, not just large language models, are prediction machines.
Yeah.
So all they're doing is, as you kind of mentioning, attempting or having all of the probability. There's basically likelihood to be right. And sometimes it's more confident in its output than it's not. So, but the one thing that they weren't explicitly programmed to do is respond no. They just basically take your prompt and they're like, okay, I'm expected to give you an output. Like, I wasn't told that I'm not allowed to, answer yes. Or like, no, I don't know this. So they're going to come up with some explanation to your question, regardless of whether it knows it or not. But
so you are able to set it up so that it says I don't know, but then you have to argument what it actually works with. Yeah.
Exactly. You have to put in those. So, and I think you'll notice this with even OpenAI, where you can If you asked about even the current events, it's going to say, hey, I don't have that in my training data set. If that was an additional module probably, or some additional code that OpenAI had to write to detect, like when a user asks about, a current event, do not respond with anything. Do not make this up, because that's an easier hallucination to control.
Yeah.
But if they didn't have that, then it would totally make stuff up.
Yeah.
But you could do that. And this is where I think it's key to understand that you can explicitly program or like condition the system to respond and not respond when the output is less confident. And then you could probably even set benchmarks for, okay, when you have a confidence or this probability of being right of 60%.
Yeah.
That's cool. Give the answer. That's better than nothing. But if it's lower than that, just say, I don't know. So you can actually do that.
I think Google even built it into the first versions of Bard. I'm not sure if it's still in Gemini, but they had a probability score, like a confidence score on the output, and that's basically the best thing I've seen for getting rid of hallucinations. And it's also something you can just dial into your preferences. For example, for us, I can't have the system hallucinate because it's like working with support requests, and but I still left like a small margin of I think 0.2. If one is like the most creative version, I put it to 0.2 in its creativity, so that it can, if the user really asks for what might I do, like it might take the context and suggest something. Like usually the button for login is named login. Like something like that, right? So, like just common sense, to not remove the whole common sense, because then it becomes less of a like traditional chatbot and more of an intelligent thing, because it just can think in the context of what it's given, and that's how I think you can approach a dial in and also make it explainable. But, and that's a big but.
I mean, it's still earlier on, so these are younger systems, so we don't know what we don't know. And I think the way that some of the, even OpenAI is approaching it, and until you kind of stumble upon a specific scenario where it's like, heck, you can't anticipate every possible edge case. So some of it you can address kind of prior to production, but some of it you will not be able to. And we're still kind of speaking about hallucination, but I think one way to, again, build that trust with users and then build confidence in the output that it is more confident in, but also surface the evidence. I think inline references, especially for models like large language models, that's basically the best that you can do, because there's just so many parameters behind those models that you can't, it's too much for basically our human brain to fathom, like the logic that's really truly behind it. So you're kind of looking at the best next thing is like
you don't even really know what part of the LM is doing or containing what knowledge, because it's just a complete system adjusted for stuff. I think there is some technology for optimizing separate areas of a language model to work more efficient. So you can have a bit of insight into what the model is doing when. But it's far off from explaining what it does. And even if you ask it to explain its steps, it might hallucinate in that too. So don't. Sometimes you even see like you have a mathematical equation and you say like, give me the answer and give me the reasoning, and it gives you the complete reasoning completely right, and then gives you the wrong answer. And sometimes it's the other way around. So we're still in the phase where this is something you have to think about when designing solutions or implementing solutions in your company. Because in the end you really have to think about what this uncertainty means for your application, and then you just have to, quote unquote, just have to figure out what this means and how you handle the uncertainties. But I'm pretty sure, and that's something that's like I would love to shout it out to everyone listening, there are ways to handle the uncertainty and to work with uncertainty. We do it all the time when we work with other humans. The outcome of their work is also uncertain in some way, shape, or form, and we also learned how to deal with that. So there is also a way of dealing with that in an automated way, so that it still improves the quality of your work, the efficiency. Honestly, I didn't mention that in the news, but the company Klarna, they integrated ChatGPT into their customer support, and they saved the equivalent of 700 employees.
Wow.
And did the 2/3 of the support requests were handled. So it works. It works at scale in 35 languages.
What?
One system.
That's awesome.
And so there is evidence that you can save a lot of money using AI, because what was it? Like 700 employees, you can calculate yourself. It's like, I think it was really, really a lot of money they saved now with that. So
right, and then I think a quick calculation: if you take 700 times average hourly rate, and then times it by the number of hours these employees work in a year, I mean, that's in like what, hundreds of millions?
A lot of millions, like tens of millions. I think it was 70 million or something.
Yeah. So can I just maybe provide two examples just to round out like the explainable AI and maybe other approaches. So there's two, like one example, maybe take something as complex as large language models, what we talked about, and like, okay, maybe there's not as many like creative solutions right now because it's just a very complex architecture and it's just like a very complex model for you to not explain. So, and I've experience working on the other spectrum where you have a machine learning model that you have parameters that you kind of architected at a smaller scale that you can actually have visibility into those parameters. So I'm talking about, let's say if you have 10 and they call them parameters or markers or signals of, for markers, basically for the machine learning that indicate or that provides the reasoning behind kind of your data. So looking at your data and looking at patterns. And those are the things that you can fine tune. So depending on the weight, the importance of that data piece, or basically you have visibility into how big of a role that particular marker plays in the output of the recommendation. So again, there's different terminologies. Again, parameters, signals, markers is another word. But basically, instead of playing with 90 billion parameters, as is in the case with GPT-4, you have tens. And so it's much easier for you to actually work with development and your data scientists and ML engineers to figure out, well, how do you explain the output? And it's actually easier even like when you implement this in the beginning because you can troubleshoot its output. You can better the machine learning because you understand what its output is. You involve users, they give you that feedback. You take their feedback and then you look at like, okay, well, what's missing here? And then it becomes much more actionable. So the way we've kind of implemented on these explainable AI is twofold. One is kind of behind the scenes. So it helps our development side of the house basically to get visibility into the output without every time going behind the scenes into each prompt or basically query and look at its output, evaluate and analyze it. We've built like an explainable AI component that actually surfaces the different weights, the importance of each signal. And then that gives us visibility as to like, okay, well, now we understand why that output was wrong and we have to do X, Y, and Z. It becomes much more actionable. But then the other lens to it is users. So when you deploy this, so as you build the solution, that's important kind of behind the scenes because the solution hasn't been deployed into the user's hands yet. But as you deploy this into the solution, because the biggest value add of explainable AI is the fact that you're building trust with the users. And so when you say like, hey, this is an AI tool, trust its recommendations, but you're not giving an explanation for how it came up with it. Like initially we launched without the explainable AI solution. Most of the questions that we received were like, why did this result come up? And Some of it, I think we bridged initially with our change management kind of practices because we explained, we did quite a few roadshows to explain how the machine learning and like these systems really work. So people had an understanding, but then the questions that came in were quite more intricate. It's like, why this exact recommendation? Why not that? And so I think that becomes important as part of your results. You have to explain this result came up because, this data was important, this piece of data was important, and this piece of data, and this is why. And then the user can go and compare two results, recommendation, and be like, oh, I see. Now you're empowering the user with the same knowledge that kind of the machine learning has behind the scenes, but you're converting it into more of a human language that they can interpret. So you're not just saying like this data, parameter and this one, X, Y, and Z. You do have to translate it into something that users find helpful in order to deciphering that feedback. And that's, again, there's different implications for when you use it kind of behind the scenes from the development, but as you're building that trust with users.
Yeah. But also behind the scenes on the development side, it's also really, really useful because having kind of a traceable and understandable trace of labels, whatever. I think it might be. I think just thinking about it, like it might be addable into inference if you say, okay, we are able to classify parts of our parameters and then at least have some labeling going on. Like you can have 1,000 labels. Just like if you enter this parameter group of weights, then this is most likely to have that label, and then you might have some way to really figure out how the generation is going, on which path it's going. Yeah, might be something. I'm pretty sure someone is working on that already.
Yeah, you can even cluster feedback, right? So like if you're finding patterns even in the feedback or the types of queries that the system runs and it just cannot handle well, but it does well on other things, you could cluster that feedback and address that part of the solution differently. So there's just, again, it's empowering not only kind of the front building trust with the users, but empowering the team to find better solutions if you know exactly how it's performing and you're surfacing that feedback to the users. So one of the other things, and I know that we've already taken up a lot of time talking about kind of the news, and we're coming up on our 1 hour, but one example that I'd love for people to explore, it isn't healthcare, so it's a little bit nuanced, but it could give you inspiration for how explainable AI works. So there's a company called Abridge, ABRIDGE, and they're a healthcare company. So what they do is they take a conversation that happens between a patient and provider. They record it. So there's no typing. And we know that that's like a huge pain point with physicians is the amount of time they spend face-to-face looking patients in the eyes. So they remove the computer out of that picture and they basically have, based on the conversation, that voice interface converts it into a narrative. And then it goes a little bit further and it organizes that into a readable note. So there's probably some system prompting, something like some large language model combination with learning involved. And they organize it into basically a chart, which, physicians, that's ultimately what they want to get to. They want to organize that conversation into something that they can ultimately bill to your insurance agency. And so they prepare it. And basically when you log into the app to see like, okay, well, what was my appointment all about? All you see is like this note, like well-organized note, but then you're like, how the heck did this machine come up with all of these and like nicely organize this? And what I love for people to explore is exactly how they surface that evidence. And so I think they do it multifold and it's just amazing. So anywhere in that note that you can click or hover over, you can click and there's a sidebar that opens and it takes you to
which part
that
of the
part of the conversation.
Okay.
So you could either read the transcript or you could play the sound. So basically you'll say like, oh, this person was complaining about something. You click and you can actually hear the conversation between the provider and patient where the patient was talking about that complaint. And so you're literally taking the conversation, the chart, and whatever. And so you're serving all of that evidence and storing it. And so that, can I really trust it? Yeah. And I think you're building trust
Of
And
course, yeah.
if anything that you're still questioning about,
And you could even over time improve on it. Like when you say like, okay, I found several points where it wasn't accurate, even if it took the right piece of audio, and then you can save that feedback, type in what would have been the better answer, and then just train on that in the future. It's interesting.
Yeah, and they have that also. So that's the amazing part. So anytime that you again hover over that piece of evidence and it plays and it gives you like a thumbs up, thumbs down, and I think you can provide even more feedback to that piece of the content that you're interested, or that piece of evidence that you were evaluating, and you can tell back to the machine that, hey, that evidence was inaccurate and for what reason. Or you could just basically give it a thumbs up so it knows that, hey, you did an awesome job actually surfacing the right evidence. So yeah, and then you have ability to replay that whole entire conversation too. So if you wanted to evaluate and you're like, oh, I remember the patient saying this, I don't see it anywhere in my notes. And that's the type of feedback you could provide to it. But ultimately, you have all of these different pieces, transcript, video, audio, and the actual note, basically that summary, that kind of paint that holistic picture. And so over time, it builds trust. So that it's doing that job. Maybe it's missing like 1 or 2 points. I can figure out what those 1 and 2 points are, but it's done 98% work for me. So like, why can't I just use it? Like, there's just such a big efficiency gains. But also, if you look beyond that, just the documentation, you're now able to spend more time face to face between the provider and patient. So instead of looking at the computer screen, typing up notes and making sure you don't miss all of that, you're delegating that altogether to AI. And again, there's ways for you to build trust and make sure that it does it in an appropriate way through that explainable AI that we were kind of just chatting about.
Yeah, and like you said, trust building, also helping in building out the solution itself beforehand. It's really an interesting topic. I think it's also a topic right into all the alignment of AI discussion, because even governments are not that happy that we're working with black boxes we don't understand fully. And we will. I'm not sure if we will have a complete solution and complete understanding of everything. Well, we can. We might get into a position soon where we at least can make educated guesses. So, but like people also always don't know what's up in my head when I talk. So there are some mysteries are not being solved this lifetime. So.
And I just wanted to encourage people that when you're implementing these AI solutions, there's ways that you could actually build these components into your architecture to explain. And there's no code tools that you could potentially use. There's been a company that maybe we'll talk about in the future episodes that does this through no code. There's other components that if you have the right skill sets on your team, to be able to, again, integrate it as part of like a custom module within your solution. In our case, we build our custom ones. But there's multiple ways. And if you wanted to kind of brainstorm or for us to elaborate further, please leave a comment and we'll happily go into the tactics and maybe even bring a guest from a technical perspective. I don't know, Edgar, if you have experience to speak to that, but we could even, find an expert that could help speak to the implementation of explainable AI, because I think it's a hot topic given some of the regulations that are already in Europe, again, in some of the states, and it's going to become more and more important. If anyone's interested in us kind of diving even a level deeper into that, leave a comment or send us a note.
Let us know. Yeah. Okay. I think we already are at the end. I think we have a really extended news section, but Elon always guts us, right?
Oh yeah.
No,
probably more weeks to come. I'm sure there's lots more.
I just love talking about the news stuff. It's just always making for interesting talk. I think talking about what's going on, and also have to all the news are coming in, and I think a lot of people are why should I bother? So if that's you, that's the channel for you.
And I think it's really a part of being kind of, why we do this is to make sure that you're kind of up to date and you know what it means. Yes, you hear our kind of take, but you stay updated and you know exactly how and what impact it provides to the industry and what it might mean for you. So that's kind of the whole reason and why we curate these news is to make sure like, will our audience benefit from hearing this, and like, will this impact some of the work that they do? I think again, some of the, hopefully by bringing that those angles of industries that this could be impacting in the short and longer term, you find it useful. So yeah, let us know if there's other things that you're curious about us covering. Always open to feedback.
Yeah. Lana. Thank you very much for again a nice talk and a nice podcast episode. I think and hope we get better over time, and hope that we could provide some value to some of you. I'm looking forward to next week. And looking forward to another week of blazing hot AI news. Let's see. I think we are close to getting some guests.
Yes.
And that's getting me even more excited. Not sure if we will be already having someone next week, but we're really close, as said. And I'll.
Can I invite some other folks? So if anyone's listening and wants to be part of
course,
our podcast, that we could spend some time kind of brainstorming ideas.
If you hear this and you think, mate, they need me, then just try.
Absolutely, we need you. So let us know.
And with that said, I will say thank you for listening. Leave a comment, leave a like, leave a subscription, as always. And have a really, really good week. And we hear you next week.
Yeah. Thank you. See ya.
Bye-bye.